Here we are, Stats and Mechanics Year 1, Chapter 10, Question 13 of the mixed exercise. I've drawn the diagram already. Two particles, one of 3 kilos, here it is, and one of m kilos, and m is smaller than 3. Okay, they are attached to the end of lighted extensible string. The string passes over a small fixed pulley. Particles are held in position. Taut string hanging. The particles are then released. The initial acceleration of each particle has magnitude of 37g. So we've got an acceleration in this direction, because that's the heavier side, of 3/7 g. Okay, and find the tension in the string. Okay, this is very similar to the last question that we did, question 12. So we're going to use both sides and set up an F equals ma on each one separately. So if we consider the acceleration there, it's 3/7. Okay, brilliant. And we've got the mass. So the ma of the F equals ma is going to be just 3 times 3/7 g. Now, if I've done that, that would suggest that this direction is plus and this direction is negative, which is different to the way I set up question 12, but doesn't make any difference. What are the forces I've got going on here? I've got a tension force in the string, and I've got a 3g force in the weight of the object. So 3g minus t, because of the plus coming down, minus going up. Okay, so there's that. Let's now do the same for the other side. I've still got a tension. I've still got a mass, which is mg, because we don't know the weight, and my acceleration is going in this direction now, and it's the same acceleration because it was light inextensible string. Okay, so again, let's set up F equals ma. F equals ma equals mass, which is m, and the acceleration is minus 3/7g. Again, being careful of those plus minus signs with all of this stuff as normal. So what do we have here? We've got mg for forces in the positive, taking away the tension. Okay, so what have I been asked to find? I've been asked to find the tension. So what can we do to find the tension in there? Well, I can do it just off this first one here, can't I? Because looking at the equation that I've put together, 3g is a number, 3/7g, they're just all numbers. I've only got one unknown, which is the t, so I can just solve this equation to find the answer. I'm not enjoying the green, I'm going to change it to orange. So what do we have there? We've got 3g minus 3 times 3/7g equals t. Just moving the t to the right and that to the left. Okay. What does that become? What does that become? 3 minus 3 times 3/7. Okay, 12/7. 12/7g times by 9.8. 16.8. So 16.8 newtons. Okay, is my tension. Lovely. Right then, what's the next bit? B, the value of m. Now I can use it and I can stick it in over here on the right hand side. Okay, so I'm just going to bring that tension over and I'm going to write mg minus 16.8 is equal to m minus 3/7g. Okay, a couple of m's to sort out there, but we'll sort it all out. Let's bring it over. What do we end up with? We end up with mg plus m3 seventh g equals 16.8. Okay, taking an m out of both of them, I end up with 16.8 being divided by g plus what is it, 3m over 7g. Okay, too far. So m is equal to 16.8 16.8 over 9.8 plus fraction. Is that m? Oh no, I took that m out, didn't I? I was going to say I don't want that m on there. I've substituted the m out. I just brought the 3g7 over and did it that way. 3 over 7 times 9.8. Okay, and that gives me 6 over 5. 6 over 5 kilos, which of course is 1.2, which, going back to the original part of the question, is smaller than 3. So that all seems grand. Is that the entire thing? Yeah, short one that. Okay, thanks.